Lab 3 for Embedded Microprocessor Systems 525615 class. So the objective of this lab was to use these push buttons to control the activity on this LED binary counter. And the way that I've set it up is that these push buttons are connected to port A, pins 0, 1, and 4. As you can see, those come out on connector 7 of the STM32 board. And then we have the output connected to port C, and that's pins 8, 6, and 5. Those are connected to these LEDs, and we have series 270 ohm resistors that allow us to not short out the LEDs. And then finally, I have a ground cable connected to the power port on here that is grounding the LEDs and the push buttons here. A picture of the setup can be seen in the lab report that I provide. So basically the way I've set it up is this one is the MSB bit 1 and LSB bit 0 for the counter. We have external button 1 here, external button 2 here, and then external button 3. And then obviously external button 1 generates this flag. It sets a flag that causes the LEDs to increment once a second. External button 2 makes it so that you increment the counter by 1, but then stop counting every second. And then external button 3 decrements the counter by 1 and then stops it from incrementing further. Finally, we have the blue button on the board that is used as a reset for the counter, and it prevents it from counting upwards. So I'll start by hitting the increment button. So if I push this, the LED starts incrementing once a second. So I'll go ahead and let that count up to 7, and I'll stop it. So I hit it at a point where it was transitioning to 0, and then it transitioned straight to 1. So if I hit external button 2, you see it counts up, and then 7, there. And then if I count down with external button 3, you see it counting down. And then obviously if I hit the blue button over here, it resets the LED and prevents it from counting up. And then I can also go ahead and keep it incrementing, and then if I hit the button here, it resets everything. All of this stuff was debounced. All of these buttons were debounced using the HAL get tick method. I count the number of milliseconds between each interrupt trigger, and what that allows me to do is debounce for about 200 milliseconds. I found 200 milliseconds was a good spot to debounce for. If an interrupt is triggered, if 2 interrupts are triggered consecutively in less than 200 milliseconds, then we decide that it's a debounce issue and then go ahead and not trigger the interrupt. The code is provided in the repository as linked in the report, and the function details are provided in the report as well. Thank you.